Hello friends, today we will discuss about unit quantities. So unit quantities are defined under a working head of 1 meter for a particular turbine having same efficiency. Okay, here efficiency meaning the efficiency will not change with respect to variation in head. Okay, these are useful in predicting the overall performance of the turbine. Okay, so these are used for prediction of the overall performance. So we have different types of unit quantities: unit speed, unit discharge, and unit power. Okay, all these quantities are defined for a head equal to 1 meter, that is working head equal to 1 meter. Now let's take one by one. Unit speed. Unit speed, and we define it as under working head of 1 meter, speed of the turbine is known as unit speed. Okay, once again, under a working head of 1 meter, the speed of the turbine is known as unit speed. Easy. So let us consider wheel speed. Wheel velocity is equal to pi d n upon 60. So okay, in order to derive or get the expression for unit speed, we will take this u equal to pi d n upon 60. Okay, we know that u is directly proportional to n, because by eliminating the constants, that is pi, 60 and d is constant because for a particular turbine the wheel diameter is fixed. Proceeding, we can write n is directly proportional to u. Okay, we need to consider the speed ratio. Speed ratio phi is equal to u by v. So just rearranging the equation, u is equal to phi into v. We know that absolute velocity is given by velocity v is equal to cd into square root of 2gh. Okay, again eliminating the constants cd, 2 and g, we get v is directly proportional to h, or u is directly proportional to h. Okay, so this approach is carried out by eliminating all the constants. So we get n is directly proportional to u, which is also proportional to h. N is directly proportional to square root of h, or directly proportional to u. So finally we get this n is directly proportional to h, which is a very important relation. That means head is directly proportional to speed of the turbine. Okay, further, if I remove the proportionality sign, I need to introduce a constant k, that is n is equal to k into square root of h. From the definition of unit speed, for a working head of 1 meter, the speed of the turbine is known as unit speed. So substituting the definition in the equation, we get nu is equal to k. Okay, so k is equal to nu. So substituting the value of k in this equation, we get n is equal to nu into square root of h. So we have nu is equal to n upon square root of h. Okay, here we can see from the equation two important relations, that is unit speed is directly proportional to, inversely proportional to head, and speed of the wheel is directly proportional to head, that is square root of head. Okay, on the same basis we'll try to get the another important parameter, that is unit discharge. Also the expression, the definition remains same. Under working head of 1 meter, under working head of 1 meter, the discharge from the turbo machine is known as unit discharge. Simple. Okay, Now let's take a basic relation Q is equal to A into V, which is discharge. So again the same approach. By eliminating the constants, we know that area is pi by 4 d square and V is CD into square root of 2gh. So if I eliminate constant, area is directly proportional to d square, velocity is directly proportional to square root of h. So we have d square into square root of h, but diameter is constant for a given turbine. Okay, as we know, the diameter of the wheel will not change for a particular turbine. So Q is directly proportional to square root of h. Again, eliminating the constants, eliminating the proportionality sign, introducing the constant k, we get Q is equal to k into square root of h. Okay, so using the definition, by definition, that is, if head is equal to 1 meter, discharge of the turbine is known as unit discharge. Okay, so substituting the values in the equation, we get Q is equal to K into 1. Okay, here Q becomes QU. So we get the value of K, which is equal to QU. So the substituting the value of QU in the equation number 1, we get Q is equal to QU into square root of H. Modifying the equation, we get QU is equal to K upon square root of H. So here an important relation which is to be observed is, that is, discharge is proportional to head. Discharge is directly proportional to head. Okay, whereas unit discharge is inversely proportional to head. So in the same way, we can get the expression for unit power also. So we know that power is rho Q GH. From the basic equation, power generated by the turbine is equal to rho Q GH under ideal conditions. So eliminating the constants, okay, we know that rho is constant for water, for hydraulic turbine. Q is directly proportional to square root of H, just now we did, and G is 9.81 meter per second square, a constant. So P is directly proportional to square root of H into H. So we can write P is directly proportional to H raised to 3 by 2. So eliminating the proportionality sign, introducing a constant K. Okay. Now we have to use the definition. So we have not defined it. We can define, if the working head is 1 meter, the power generated by the turbine is unit power. Okay, so that is, if head equal to 1 meter, we can write power is equal to unit power. So using the definition, we get P is equal to K. Here P becomes PU, okay, because the working head is 1 meter. So substituting this value in the equation, we get P is equal to PU H raised to 3 by 2. So we can rearrange and write the equation. So this is unit power. So here we can see an important relation. Power is directly proportional to head, h raised to 3 by 2. Okay, this is how we can get the expressions for unit power and the unit discharge, also unit speed. Thank you.